I'm going to show you how to use the Excel Companion Significance Testing Workbook to test hypotheses about proportions. If you're watching this video, I'm assuming you already understand a few essential concepts. I'm assuming that you know how to describe and compare nominal and ordinal level data with proportions. I'm also assuming that you understand the foundations of inferential statistics, especially the null hypothesis significance testing framework. This video is for people who already know what significant tests for proportions are and now want to learn how to conduct these hypothesis tests with Excel. It's easy to test hypotheses about proportions with the Excel Companion Significance Testing Workbook. You can download this workbook from the Excel Companion's website. You just input a few values specific to the problem you're trying to solve. The worksheet does the calculations and shows you the results. To test a hypothesis about one sample proportion, you input 5 values into our worksheet. 1. The hypothesized value. 2. Alpha, which is your type 1 error tolerance. 3. The hypothesis direction. 4. The sample proportion. And 5. The sample size. These values should be given in the problem you're working on. After you enter this information, the worksheet shows you the p-value for the null hypothesis test, reports its conclusion, and shows you how it calculated test statistics. You input the same information to test a hypothesis about the difference between two sample proportions, except you have two sample proportions and two sample sizes to enter. To see how it's done, let's work through a couple of examples. This is an example of a two sample proportions test. So I'm going to use the two sample difference of proportion test worksheet. The example reads, a researcher studies the effect of a defendant's age on juries using a randomized experiment. 75% of subjects in 84 shown a young defendant would find him guilty. 66% of subjects N of 79 shown an old defendant would find him guilty. Were subjects significantly more likely to find the young defendant guilty compared to the old defendant? Interesting question. So the worksheet inputs the null hypothesized difference between the two groups is 0. So we are just simply testing whether subjects shown the young defendant are more likely to find him guilty than those shown the old defendant. The alpha value isn't specified, so we'll leave it at 0.05, the conventional level for significance testing. So the research hypothesis depends on which group we specify as the first proportion and which is the second, which is the first sample and which is the second sample. And let's be careful now to follow the prompt. Were subjects significantly more likely to find the young defendant guilty compared to the old defendant? So we're comparing the proportion guilty in the young group to the proportion guilty shown the old defendant. So the first sample would be those shown the younger defendant, the second sample shown the older defendant. So the research hypothesis, or what we're testing, is whether P1 is greater than P2. So if P1 is greater than P2, it would be a positive value. So I'm going to select the second research hypothesis, and let's just think about this. Proportion 1, it's going to be the young defendants, the proportion they find the young defendant guilty, minus the proportion finding the older defendant guilty is going to be greater than 0. So that's going to be true if this is positive value, and if it's a statistically significant positive value falling in the red area here, the null hypothesis rejection region. Let's put in the values. Now the sample 1, the first proportion, says that 0.75 of subjects found the young defendant guilty, and there were 84 subjects in that group. The proportion in the second group, I'm just convert 66% to proportion is 0.66, and in the group shown the older defendant, there were 79. So we get some results now. Hypothesis test results. The p-value is 0.104. We failed to reject the null hypothesis. The probability of observing this 9 percentage point or 0.09 proportion difference, if the null hypothesis is true, is 0.104. So even though the more subjects found the young defendant guilty than the old defendant, and it was a positive value, that positive value could arise by chance fairly frequently, and so we would fail to reject the null hypothesis. There may be some indication that it's true. This is a fairly small p-value, but it's not less than alpha, not less than 0.05. So this researcher might want to increase the sample size or gather some additional independent observations to have a better test of the hypothesis. We might say this is more just underpowered because of the sample size and not necessarily a false hypothesis. But the researcher has failed to disprove the null hypothesis. These results could have happened by chance fairly regularly, so we should not dismiss the null hypothesis. So to answer the question, were subjects significantly more likely to find the young defendant guilty compared to the old defendant? The difference is not statistically significant.